Hello everyone, class 12th. Topic is reduction of carboxylic acid to prepare alcohol. From carboxylic acid we can also prepare alcohol. In previous video we have understood how aldehydes and ketone on reduction produce alcohol. Carboxylic acid general formula is this one. So let's reduce it. I already told you a technique how to do a direct reduction of organic molecules. Reduction means loss of oxygen. So firstly you have to decrease the bonding, like two bonds are there. In next molecule make one bond and satisfy the valencies with hydrogen. Oxygen valency will be satisfied by hydrogen, carbon valency will satisfy by hydrogen. Now listen very carefully in organic chemistry. Whenever in organic chemistry you are getting such condition, means two oxygen atom on same carbon, or such conditions are also available there. Negative charge is balanced by some cations like sodium positive. On a same carbon, two oxygen groups with a lone pair. This condition you can watch. They are highly unstable conditions. Because on same carbon, if two oxygens are present with their lone pair, repulsion or steric hindrance problem will be arised. In such condition, always what will happen? Out of two oxygens, one oxygen will break bond from carbon. Suppose this is breaking bond from carbon. So obviously when oxygen will break bond from carbon, electrons will go toward oxygen side, and one oxygen will break bond from its neighbor. Obviously its neighbor will be less electronegative than oxygen, so electrons will go toward oxygen side. Now two electrons here, and carbon will have vacant orbital when oxygen will break bond from carbon. So oxygen will shift electrons with carbon toward carbon, due to which this will generate, and A and OB they will release out. Same here, like this oxygen will break bond from carbon and will get electron, due to which vacant orbital will generate. That vacant orbital will be satisfied by neighbor oxygen by shifting lone pair electrons here, and again CO will generate out. Please note down this condition. In organic chemistry, whenever you are getting this condition, satisfy your carbon like this. Two oxygen atom on a same carbon will never be stable. So same condition after the reduction of carboxylic acid I am getting. Check. OH on same carbon. So steric hindrance problem, lone pair, crowding, repulsion is there. So out of two oxygen, let's break this carbon oxygen bond. Both electrons will go toward oxygen. On carbon, vacant orbital will generate, which will be satisfied by this oxygen by breaking bond from hydrogen, and will shift here. R between carbon and oxygen, double bond will generate. What about H? It will release out as H positive because it has lost its one electron. This was the electron of hydrogen, which is now with carbon. And from here, because oxygen got one extra electron of carbon, so already it was carrying two lone pair. Now it will have three lone pairs with a negative charge because it got one extra electron of carbon. H positive, OH negative will combine to generate H2O, and this hydrogen will remain as it is. So please check what is generated. Aldehyde is generated. Means carboxylic acid on a first reduction will give you aldehyde. Now on reduction of aldehyde, I already told you, apply same technique. Two bonds are there. Next reduction will give you one bond. So just decrease the bonding with oxygen on every stage. Lines will be satisfied, valencies will be satisfied by hydrogen. Check this one. What it is? Alcohol it is. What is the degree of this alcohol? 1 degree. Because the carbon which is carrying OH is directly connected to one carbon. So 1 degree alcohol. Means carboxylic on reduction Firstly will generate aldehyde, and on a second stage reduction it will give you 1 degree alcohol. Now for that obviously we need reducing agent. Which reducing agent I am using here? Lithium aluminium hydride, or we can use also BH3, borane. So first I will show you reduction through lithium aluminium hydride here. Let's check the mechanism. Before mechanism, let's solve one reaction directly so it will be clear to you. Like if it is written, this is the carboxylic acid, propane 1-oic acid, and in reaction lithium aluminium hydride or BH3 is given, and it will be followed by hydrolysis again. After using lithium aluminium hydride or BH3, second process you need to apply to produce alcohol is hydrolysis. So this is the condition of reduction, obviously. So directly on a first reduction it will give me aldehyde. This carbon will get reduction, propane 1 al, and again the second time reduction lithium aluminium hydride, same reducing agent will bring this whole reduction up to alcoholic level. This one, on this carbon keep on decreasing, bonding with oxygen. You can check on this carbon how many bonds were there with oxygen. 1 2 3. Next time how many we have? Only 2. Next time only 1. So reduction means decrease bonding with oxygen and increase bonding with hydrogen. Here we don't have any hydrogen with this carbon. Next time one hydrogen is joined. Next time 2 hydrogens are joined in this fashion. Now let's understand the actual point, mechanism. How lithium aluminium hydride is reducing carboxylic acid. In previous video we have already understood the condition of lithium aluminium hydride. Around aluminium 4 hydrogens are there, 3 are making normal sigma bond, 4th is making date bond, due to which it is carrying a negative charge. During reaction, because aluminium is unstable, what it will release out? Hydride. Because hydrogen is more electronegative than aluminium, the both electrons will go toward hydrogen. Now because aluminium is losing extra electron, because this extra electron is going with hydrogen, so the negative charge of aluminium will finish, and at the place of this bond vacant orbital will be generated, and this hydrogen will release out as hydride. One electron is its own, and one electron it's of, I can't say it's an electron of aluminium, because this electron it got from lithium. That's why it has made a dative bond with aluminium, and during reaction it is getting it back and releasing out itself as a hydride ion. This one. Now hydride ion is a nucleophile. What it wants? A positive particle. Where we have positive particle? Carboxylic acid. Who is positive particle here? Oxygen is connected with carbon, so obviously oxygen is gaining electrons from carbon, like this. So carbon is positive particle here. Oxygen is connected with hydrogen, so oxygen is gaining electrons from hydrogen, so hydrogen is also a positive particle. Which will be a more positive particle? Hydrogen here. Because hydrogen electronegativity is 2.1 and oxygen electronegativity is 3.5 and carbon electronegativity is 2.4. So here we have more electronegativity difference. So that's why this hydrogen is more positive as compared to carbon. Now that's it. Hydride is there, negative particle. Hydrogen is there, positive particle. Let's attack. Bond will break. Both electrons will go toward oxygen side. So this particle will become RCOO negative. Oxygen is carrying 2 lone pair already. Now one more pair is coming, so it have a negative charge. Hydrogen will release out as H positive because it is losing its electron. This electron, H positive, H negative will combine to create sigma bond hydrogen gas, H2 gas. In this fashion, this alkoxide ion will be generated. Now, what will happen with this alkoxide ion? Let's check. The role of hydride is finished, so I am rubbing it. Now the alkoxide ion which is generated over here, the negative oxygen will be satisfied by lithium, Li positive, and here we have aluminium with a vacant orbital. Vacant orbital have a tendency to gain 2 electrons. Oxygen have a lone pairs over there. Let's combine this aluminium with oxygen. Which bond will generate? Dative bond will generate. Like this. Now when oxygen will make bond with aluminium, we know oxygen can't make 3 bond. If it is making 3 bonds, so it will become unstable. So obviously what it will do, it will break bond from carbon, and which electrons it will shift toward aluminium? Pi electrons. First understand aluminium condition. Right now aluminium is neutral because it don't have any extra electron. But when oxygen will provide electron, it will have extra electron of carbon toward it. Like this. Due to which, again it will carry a -1 charge. 2 electrons are there. 1 electron is of oxygen and 1 electron was of carbon. This one, which it has shifted toward aluminium. Due to which, around carbon vacant orbital will generate with a +1 charge. And O negative is getting satisfaction from lithium. Now what will happen? Aluminium again -1, unstable. How it can get stability? Will break bond from hydrogen. Both electrons will go toward hydrogen and hydrogen will release out as hydride negative. Hydride negative will combine with carbocation, this one, like this. So we will get R C O Al 2H will left there with a vacant orbital on aluminium, like this. H is here, O negative is available, lithium positive is available. Now check. On one carbon, 2 oxygens. What I said about this condition, it is a highly unstable condition. How it can get satisfaction? Look, this oxygen is negative, -1 means extra lone pairs it have. So obviously it will shift lone pairs toward carbon because this oxygen is breaking bond from carbon, because these 2 oxygens have a problem from each other, repulsion. That's why one oxygen saying, I am going, you can stay here. So while this oxygen was going out from the molecule, it is getting both electrons because oxygen is more electronegative than carbon. Both electrons will be transferred toward oxygen. Due to which carbon will be vacant orbital, on carbon vacant orbital will generate. That will be satisfied by neighbor oxygen, because neighbor oxygen is carrying 3 lone pairs. 1 extra lone pair is there. After this, condition will be this. Between this carbon and oxygen, double bond will generate. And now this oxygen will carry 2 lone pairs because one it has used with carbon. This oxygen will carry now 3 lone pairs. Aluminium is there with vacant orbital, hydrogen is there, like this. This vacant orbital will be satisfied by lone pair of oxygen, means dative bond. So this will become double bonded -1 H H. This is the condition. Now check what we got. Our one particle of carboxylic acid is converted up to aldehydic stage. This one. Now wait, mechanism is not over yet. This particle still have a power. What power? It is unstable. Again, same technique it will apply. What it will release out? Hydride. Here I am writing hydride. And itself will turn into AlO vacant orbital H. Okay, keep in your mind one aldehyde particle is already generated. I am rubbing it. Let's write it on side. One aldehyde particle is generated, or one carboxylic acid particle is changed to aldehyde particle. Okay. Now the aluminium hydride which we have used, aluminium O4 negative, is changed itself to this one, this particle, AlOH H negative. And what this particle has done, it has again released one more hydride. Here I am writing, and change itself to this one. तो यहाँ तक की कहानी तो ये थी, आप ध्यान से चेक कर लो. One particle of carboxylic acid changed to aldehyde due to one particle of aluminium hydride, which further turn itself to AlOH vacant orbital, and again it has released hydride ion. What this hydride ion will do? It will go for the second particle of carboxylic acid, RCOOH. Again, same mechanism it will start. Here hydrogen is positive, so hydride will start attacking on positive particle. Again, bond will break between oxygen and hydrogen. Hydrogen gas will release out. This particle will turns to RCO negative. This one. This oxygen will be again stabilized by lithium particles. And what about this lone pair oxygen? Watch here. The aluminium hydride which we have used, it has changed itself up to this molecule. And in this molecule, again aluminium have a vacant orbital. Obviously, this vacant orbital will again start the same process. It will make a dative bond with this oxygen. Let's make. Aluminium will join with this one. Oh, sorry, oxygen is here. This oxygen will break pi bond from carbon and will provide these electrons to aluminium. Like this. And don't you think, because aluminium is getting one electron from oxygen side, look, this electron was of carbon. Now it is transferring toward aluminium in this bond. This electron which is toward aluminium was of carbon. Now it is toward aluminium. So aluminium again will become negative particle. And this carbon will become positive particle because it has lost one of its electron. Now again, what will happen? This molecule I am writing here. Molecule, this mechanism is little bit complicated. So keep on writing every step when you will understand it from video. This was the condition. Keep on writing every step because time to time I am rubbing it. So that's why you need to compare with initial conditions. So it should be written to you in front of you. Now, this is positive particle of carbon. This is aluminium hydride, again unstable. What it will do? Again, it will break bond from hydrogen and will release out its hydride like this. And this hydride will join with carbon and will make carbon neutral. And this part is. Now check aluminium, because aluminium has lost one electron, so its negative charge will finish and vacant orbital will generate on it. It is a neutral now. Now again the same condition, carbon is carrying two oxygens with a lone pair. What I said about it, it will stabilize like this because it's a sterically hindered condition. This molecule will turns to R, CH double bond O, and this oxygen will have three lone pairs, negative, Al, O, vacant orbital. This one. This vacant orbital will be satisfied by lone pair, due to which aluminium will get -1 charge on it. Means fourth bond will be a dative bond from an oxygen side. So this is AlO2 -1. Now let me sum it up. Means two molecules of RCOH plus one molecule of lithium aluminium hydride made, watch here, second aldehyde particle. Two molecules of RCOH means aldehyde, and this particle turned itself to AlO2 -1. And this negative charge will be satisfied by lithium. With the release of how many hydrogen gas particles? Remember the very first step, two H2 gas particles will release out from here. This one. Means two particles of carboxylic acid due to one lithium aluminium hydride will turns to two aldehydic particles. And this is the condition of lithium aluminium hydride will happen there. Now in balanced equation, we will use 4 carboxylic acid particles. We have done right now, 2 particles of carboxylic acids are reduced by 2 particles of lithium aluminium hydride. 1 particle of lithium aluminium hydride. So here total 3 lithium aluminium hydrides will be utilized. Let me tell you why. 4 carboxylic particles due to 2 lithium aluminium hydride particles will turn themselves to 4 aldehyde particles plus 2 lithium aluminium oxide particles plus 4 hydrogen gas particles will generate out. I have shown you mechanism with 2 particles and 1 lithium aluminium hydride, 2 particles of carboxylic acid and 1 lithium aluminium hydride. Again, second lithium aluminium hydride with same process will react with 2 another particles of carboxylic acid, and total 4 aldehydic particles will generate. Means out of 3 lithium aluminium hydride, 2 will be utilized to generate 4 aldehydic particles from 4 carboxylic acid particle. Now what about third lithium aluminium hydride, sir? Remember previous video in which we have done reduction of aldehyde with lithium aluminium hydride. Yaad hai? When you will check its mechanism, you will find out 1 lithium aluminium hydride was changed itself to this condition. ध्यान से चेक कर लेना आप लोग, आपको पता लग जाएगा. One lithium aluminium hydride was able to react with 4 aldehydic particles, and it has given us this. After this process, which process we have applied there? Hydrolysis. Hydrolysis means H positive OH negative will break aluminium oxygen bond. Oxygen is more negative. Here aluminium was -1, but because oxygen is more electronegative, so these electrons are toward oxygen side. So oxygen is partial negative over here, which is attacked by H positive particle, bond break, and this particle will change itself to RCH2OH, alcohol. So in this fashion, 4 alcohol particles will generate out from here. So out of 3 lithium aluminium hydride, 2 we have used to convert 4 carboxylic particles into 4 aldehydic particle, and third lithium aluminium hydride was used to convert those 4 aldehydic particles into this one, metal alkoxide, and then on hydrolysis we will get how many alcohol particles? 4 alcoholic particles, 1 degree alcohol. So if I sum it up, so I will write this equation like this. 4RCOOH reacts with 3 lithium aluminium hydride to give us first 4RCHO plus lithium 2 lithium AlO2 plus 2 H2 gas. This one, 4H2 gas, 4H2 gas, and this 4RCHO, I should write like this, 2, and this 4RCHO are further reacted separately. I am writing it with 1 lithium aluminium hydride to give us this one. This particle. And finally, on hydrolysis of this particle, you will get 4 particles of RCH2OH, and this aluminium will turns to aluminium OH4 negative, which will be balanced by lithium. This is the whole process. Please check. In this video, the new mechanism is for you is from here to here. And from here to here, we have already done in previous video when we have reduced aldehyde to alcohol. That's it. The video was quite long, but it will be useful for IITs and NEET. Thank you very much for watching the video.